Right. So let us come to the Newton's laws of motion. And how many laws are there, Nana? 3 laws were there. Okay. Okay, Nana. Can you see this PPT, Nana, on your screen?
Yes, sir.
Okay, Nana. So let us discuss about Newton's first law of motion, Nana. Okay. No.
Yes, sir.
Right, Nana. So let us think that one box is kept on a table, Nana. One box is kept on a table. Okay. Nana, listening or not?
Yes, sir.
Okay, Nana. And that box will be there on that table until what time?
Sir, until an external unbalanced force acts on that box.
Very good, Nana. What do you mean by unbalanced, Nana?
Sir, unbalanced force is the force greater than friction.
Greater than friction. Unbalanced, you said, Nana. You only said unbalanced.
Yes, sir.
Unbalanced means what? Balanced means what, Nana?
Sir, balanced force are those in which the resultant of all forces is zero.
So that point you have to say, Nana. Unbalanced means what? The resultant force will not be zero. That means some net force will act on it. Isn't it?
Yes, sir.
Okay. So that means until and unless you are applying force on that particular box, whether that box will move or box will not move. And Arnav,
Yes, sir.
whether box will move or not.
No, sir.
Box will not move until unless you apply an external force, unbalanced external force. Very good, Nan. So that only will be called Newton's first law of motion, Nan. Suppose an object is in a state of motion, Nana. An object is in a state of motion. Up to what time that object will be in a state of motion, Nana? Anyone?
Sir, until we apply some external force to stop it.
Very good, Nana. So until unless an external force acts on it, the object which is in a state of motion will be in a state of motion only. So this statement is only expressed as what, Nana? Newton's first law of motion. So maybe that is there on that particular screen. Once you read it, Nana. Bhumika.
Yes, sir.
Read, Nana, Newton's first law of motion, whatever is there on your screen.
Sir, a body remains in the state of rest or uniform motion in a straight line unless and until an external force acts on it.
Very good. So whether that statement is true or wrong?
True.
True. So this statement is only called what, Nana? Newton's first law of motion. What it will be called? Newton's first law of motion. And do you know what is the importance of a Newton's first law of motion? Do you, Nana? Anyone knows what is the importance of a Newton's first law of motion?
Sir, inertia.
Inertia.
Sir, I didn't get the question.
Question. What is the importance of a Newton's first law of motion? That statement gives some meaning for us, Nana. Whatever the statement just now Bhumika read, that gives some sort of sense to us. And what is that sense which will be given by Newton's first law of motion? That is only called importance of a Newton's first law of motion, Nana. And let me say, Newton's first law of motion importance is nothing but this Newton's first law of motion can define inertia and force, both, Nana. What is the importance of a Newton's first law of motion? Newton's first law of motion can define inertia and what, Nana? Force. Is it right?
Yes,
or no?
sir.
Right, Nana. So the importance of a Newton's first law of motion is nothing but it can define both inertia and force, Nana. In the statement itself, both the meanings are there, Nana. So how to understand them? Let me start about inertia first, and after explaining about inertia, let us discuss about force also. And after discussing about force, we are going to learn about second law also. But let us first try to learn about inertia, Nana. And can anybody say what is the inertia? What is the inertia?
So the natural tendency of all the object to oppose the change in state of rest or of uniform motion.
Very good, Nana. Arnav, you are reading the slide or you are saying your own, Nana? Bhumika?
Sir, no, sir, I'm saying own, sir, not reading the slide, sir.
Okay, okay. Right, very good, Nana. Arnav, tell me, Nana, what is your answer?
Sir, inertia is that property of a body due to which it resists a change in its state of rest or uniform motion.
Very good, Nana. Okay. So, let me say, the inherent property of an object. Inherent, Nana. That means inside of an object only that property will be there. That property lies inside of that object. So the inherent property of an object which cannot change its state will be called what, Nana? Inertia. As you said, what it will do, Nana? What object will do? Object will resist the change which occurs in that particular object. Now, have you understood, Nana?
Yes, sir.
Okay. Bhumika, have you understood?
Yes, sir.
Milan, tell me, Nana, whether you understood or not. At least you give me message. Sahas and Milan, whether you are listening or not. Okay. Sahas, tell me, Nana. Okay, Nana. So the inherent property of an object which cannot change its state. Which state, Nana?
The state of rest or motion.
Very good, Nana. Whether the state of rest or state of motion, it can't change. So that inherent property will be called what, Nana? Inertia. So just now only, what is the statement of a Newton's first law, Nana? Until and unless an external force acts on any object. The object which is in a state of motion will be in a state of motion only. The object which will be in a state of rest will be in a state of rest only. And I gave example also. What example I gave, Nana? One box I kept on a table, and that box will be there up on that table until what time? Until you apply external force. So until you can't apply any force, until you apply force, the object will be there on the table only, Nana. That means object which is in a state of rest tries to be in a state of rest only. The object which is in a state of motion tries to be in a state of motion only until you apply some external force on it. And that only will be called what, Nana? Inertia. And how many types of inertias will be there, Nana, generally? Do you know?
Sir, 3 types.
3 types. Very good, Nana. What are those 3 types of inertia?
The first is the inertia of rest, second is the inertia of motion, and third is the inertia of direction.
Very good, Nana. Inertia of rest, inertia of motion, inertia of direction. Very good, Nana. Can you say, Nana, what is the inertia of rest? Okay, Nana. So before going to start about inertia of rest, inertia of motion and inertia of direction, let me ask you, with what you can measure this inertia? With what you can measure the inertia? Maybe that is there on the screen.
The mass.
Very good. How the mass, Nana? That is there on the screen and you are saying?
Yes, sir.
So you are reading whatever is there on the screen.
Yes, sir.
Can you explain how mass of an object can decide about inertia or can measure about inertia?
Sir, if inertia will be greater, the more force will be required to move the object.
Very good. But I am asking how mass of an object will measure the inertia.
Sir, I was coming to that, sir. Sir, to move an object, sir, we determine its mass. Sir, if mass is something, so sir, we have to apply a force counter to that in order to move.
Okay, you are not getting my point, Nana. You are saying that mass can measure the inertia. How can you say mass can measure the inertia? How it is possible? Mass can decide the inertia. Okay, let me ask you, Nana, for all of you. Bhumika, give me answer, Nana. Bhumika.
Yes, yes, sir.
Okay, Nana. Now 2 objects are there, Nana. One object is having 100 kg and one object is having 5 kg, Nana. Which object you can make move easily?
The object which has the mass of 5 kg.
Very good. So 5 kg mass object you can move very easily. And what about 100 kg, Nana? Bhumika.
It will require a large force to move.
It requires large force to make it to move. That means inertia will be more for more mass object or less mass object?
The more mass.
Very good. So that means if mass is more for an object, whether the inertia will be more or less?
Sir, more.
More. Very good, Anna. So that means if mass is more, inertia will be more. If mass is less, inertia will be less. That means if mass is very less, very small mass is there, Nana, quickly it can change its state. But if mass is more, It can't change its state very easily. So that's why inertia will be more for the object which is having more mass, and for the object which is having less mass, the inertia will be less, isn't it?
Yes, sir.
Okay, Nana. So let me ask one question, Nana. One bus is there, Nana. Big bus is there, in which 40 passengers are there, and one car is there, Nana. One car is there which is carrying 4 passengers. Which will have more inertia?
Sir, the bus.
Very good. Bus carrying 40 passengers. Why? Because mass will be more in it. That's why inertia will be more for it. Is it clear, Nana?
Yes, sir.